Okay, welcome to my ELM test prep series. I'm James, and what I'm going to discuss here in this episode is parallel lines. Well, the idea of parallel lines, we kind of have an idea about that, and you probably know this already, that parallel lines never touch each other. No matter how far they extend outward, they will not cross each other. Well, that's a fundamental definition of parallel lines. They must not cross. But we also tend to define lines mathematically and algebraically. We look at the slope of this line and the slope of this line, and if they're parallel, then those slopes are equal to each other. And that's another definition of a parallel line, that the slope of the one line equals the other line. As long as they're not right on top of each other and become the same line, then you have two lines that have equal slope and therefore are parallel. Well, it doesn't really matter which direction they go. They're not going to cross, so the slope of the one equals the slope of the other. Parallel and vertical, parallel in any direction. Alright, so that's a fundamental idea of a parallel line. Let's see if we can talk a little bit about what that means to us, maybe geometrically. If I have two lines that are parallel and I draw some line down through this that is kind of crooked here, but I'm going to say that it's a straight line. And I'm also going to say that it's perpendicular. Well, if we were in a building where this was some wall and these were floors, the walls would be perpendicular to the floors no matter what floor you were on. Well, since they are perpendicular, that makes these angles a right angle, and also makes it equal to 90 degrees if we measure that angle. Okay, so that's fine and well for right angles, but we don't always have right angles with parallel lines. And so our parallel lines do not always go in a nice horizontal direction. So I'm going to take a couple parallel lines here, and I'm going to indicate that these are parallel with these two arrows. Let's look at corresponding angles. This angle here is in a corresponding position to this angle, a similar position with reference to the transversal and the parallel line. It's between the two of them to the right. Well, this is between the two of them to the right and above. Well, this line would be to the left and above, and this line would be to the left and above. So these would be equal angles. These angles would be equal, and these would. Corresponding angles turn out to be equal to each other with regard to a transversal cutting a parallel line. Well, and we also see that this is a straight angle, so we could say that these two are supplementary. Well, I know that this angle is equal to this angle here by vertical angles. So this angle and this angle are also equal by vertical angles. And I see that they are also supplementary. Well, these are supplementary, and then this angle equals that angle. And then I notice something. Well, the opposite interior angles are equal. This equals this, and this equals this. So we could come up and say, well, opposite interior angles of parallel lines with a transversal are equal. But I also notice that these are supplementary and these are supplementary, and I see that these are then supplementary. So interior angles of parallel lines with a transversal are supplementary. The same side are supplementary. Well, the outside ones are supplementary. The inside ones are supplementary on the same side. And then on the outside at the bottom here, they will be supplementary on opposite sides. So it's just some ideas of the idea of how these all work together. And I can be given one angle here. And the measure of this, we'll say this is a 70-degree angle. With that one piece of information, then I can find all of the other angles using these various rules. And corresponding angles of parallel transversal are equal, and therefore I can find them all, either through complementary or supplementary or vertical rules. Okay, so let's look at the idea of, I used the term supplementary. And essentially what that means is I have two angles that if I add those two angles, I will get a total of 180 degrees out of those two angles. Well, this is a straight angle, and a straight angle is 180, so if I chop it into two pieces, those two pieces should add up to 180. So that makes sense. Supplementary angles are two angles that add to 180 degrees. Well, the other term you might run into is the term complementary. And that essentially is saying that I have two angles A and B that add up to 90 degrees. And this being a right angle, it equals 90 degrees. So the parts, if I cut it into two pieces, should also add up to 90 degrees. So complementary angles add to 90 degrees. And if you want to think of the C for complementary and draw a line down through it and see, oh, well, that looks like a 9. Oh, yeah, 90 degrees. Complementary angles add to 90. Well, we have a similar little thing with supplementary angles. We take the word S for supplementary and we draw a line through it. Oh, it's an 80. Well, it's obviously not 90 degrees. It's 80 degrees, but I don't know an 80 degrees, so I'll throw a 1 in here. Oh, yeah, that's right. Supplementary are 180 degrees. Another way to think of that, S for straight angle is 180 degrees, so that works also. All right, so let's say that I want to use this idea of parallel lines in some manner. So I have some triangle, ABC. And then they go and say, well, we have a line inside of this triangle that we drew. And although it doesn't look parallel, I'm going to state that that line is parallel to this line down here. Well, this forms a triangle here, and the outer triangle, of course, is already there. Well, let's use this idea of corresponding angles, or corresponding angles of transversal and parallel lines. Well, these two are parallel, so this line cutting through here would be considered a transversal. So this angle and this angle are in corresponding positions, and so they would be equal. Well, we also have parallel lines with the transversal here, so this angle and this angle are in corresponding positions relative to the transversal. And then, of course, this angle up here, both triangles use that same angle, so it's equal to itself. And now we can say, due to the fact that these angles in corresponding positions between the two triangles, the corresponding angles are equal. The small triangle, this angle is equal to this angle in the larger, this angle, the small one, is equal to this in the larger, and this angle is the same for both the small and the larger. So all their angles correspondingly, all their corresponding angles are in fact equal. And as such, I can say that they are similar triangles. Well, that's useful information if I want to somehow decipher something out of this. Given certain information, I can then find other information about the other parts of these various triangles. But the key lies here in the fact that these two bases were defined as parallel lines, setting up the idea of transversals and allowing us to then find out that the small and large triangle were in fact similar triangles. Well, there you go. That's a little bit about parallel lines and what they can do for you. I hope that was helpful. Anyway, this is James. This is my ELM test prep series. If you find this informative, you might want to look at some of my other videos. This is primarily aimed at students who are planning on taking the ELM test for college. So, have a good day.